Okay, this is just a little bit more about that normal probability plot if you're interested. Basically what the normal probability plot is, it's taking the data, finding a percentile, and then calculating a z-score for that percentile. Here's the symmetric data from the back of that packet. Here's the left skewed data. Here's the right skewed data from the back of that packet. So I'm finding the percentile, so these are the data's in order. If you look at the number, the way that this percentile formula is working, you would think that 8 would be in the 0 percentile. There's an adjustment here in this formula. Some textbooks teach it this way, ours didn't. Regardless, the normal probability plot is still calculated with this adjustment. So we take, what I've done here is that first value, that's the first value, so 1 minus 1, so there's 0 values below it plus this 0.5 adjustment, divided by the total number of values. So a score of 8 is the 6th percentile. Here, again, there's this adjustment. So I've got, this is the second value, minus 1. So there's one value below it, plus 0.05 divided by the total number of values. And then what I've done is I find the z-scores for those. I did the same thing for the left skewed. I did the same thing for the right skewed. What the normal probability graph is it's taking the x value, so this column, against the z-score column. These values are nicely spread out. It's symmetric, so they're evenly kind of spread out there. So when you plot it against those z-scores, you'll kind of see just this nice smooth curve there, or nice flat line, straight line. With our left skewed data, what's happening is that we have a lot of values over here. And so like, you look at 63 and 64, they're not that far apart. But since this is the 63rd, there is 12 minus, there's 11 values below this, and this one is the 64, so there's 12 values below that one. So their percentiles are pretty far apart, and then their z-scores are far apart. So then when I graph those, I have two x's that are close together, but then I have two y's that are kind of far apart. So we get this like uptick here in a left skewed. And then the opposite happens here with the right skewed. So in the right skewed, I have a lot of values here, like, so I have two 19s right here. And again, the way this is working is that this 19 here is going to have a percentile 12. This one has a 19. But like 22 and 24 aren't that far apart. But again, this is the fourth value. There's 3 below it. This is the fifth value. There's 4 below it. So there's percentiles are far apart. Those z-scores are far apart. So the y's are far apart, but the x's are close together. So then I'm getting this like cluster over here. That's basically what's happening with your normal probability plot.